Hello, in our video, we will talk about algorithm analysis. And in this video, we'll cover definition of algorithm. We will talk about algorithm analysis and why it's important. We will talk about running time, time complexity, and how we're going to do the algorithm analysis. To start with, what is an algorithm? An algorithm is a description of a procedure that is made by steps in order to perform a specific task or solve a specific problem. And this procedure will take a finite amount of time, and it consists of finite number of steps. A data structure, on the other hand, is a way to organize and store your data. Whenever you have a set of data, that may be a large set of data, you need to find a proper way to store this data such that accessing this data or doing the operations that are needed on your data will be efficient. And by efficiency, we mean operations run in an optimal amount of time, in a minimum amount of time, as minimum as possible. So why algorithm analysis is important? Algorithm analysis is important because choosing a good algorithm will make a big difference in terms of time that it takes to give you results, and also it may also give you good results in terms of space complexity. By running time, we mean the time the algorithm takes to run, to execute, to give you results. And by space space complexity, we mean how much space your algorithm is using while running, while executing. Now, in this video, we focus more on running time, on time complexity. This doesn't mean that space complexity is not important, but usually the time complexity is the factor that is that affects the efficiency of algorithms more. So in our algorithm analysis, we will focus on time complexity. If you look at this graph, you can see we are measuring the time. Okay, so here the y-axis is time in seconds, and the x-axis is the size of the array, and we are sorting this array using a sort algorithm that's called insertion sort. So, and we are measuring the time that this algorithm, this insertion sort, is taking while the size is increasing. And you can see that the time that the algorithm takes increases as size of the array increases. Okay. The runtime is affected by several factors. One of them is the size of the input, and also the different types of the input. So, for example, if my input data, okay, was almost sorted or sorted, the insertion sort may run faster. Okay. However, if my algorithm and my data were inversely sorted, for example, I want to sort my data in increasing order, and my data happen to be sorted in decreasing order. So in this case, your algorithm will work the most, and it will affect the running time of your algorithm. Number of primitive operations. The number of operations that your algorithm is doing will affect the running time. Hardware of the machine, the hardware, the speed of the CPU, the memory, all these hardware features also affect runtime. Also, the software environment, the operating system, the language you're using, the compiler you're using, the properties of the language you're using also affect the runtime. But mainly, what we're going to look at, okay, we will assume that we have a good hardware properties, good hardware features, and also appropriate software environment. So basically, we will focus on the first three factors. There are two ways to measure running time: experimental analysis and theoretical analysis. Experimental analysis is simply like running your algorithm and measuring the time for different input sizes, for different data sets, and just drawing a graph like the one that is here. Needless to say, experimental analysis is a long procedure. It's hard to make it accurate. We'll talk about it in a few seconds. And also, it has a number of drawbacks. So that's will take us. This will take us to theoretical analysis, which we will use in our algorithm analysis. Experimental study, first, in order to do the experimental study, we have to implement our algorithm. We have to write down the program, and then we have to run this program and record the time that it takes. We have a lot of issues here to talk about. First, what if I have 2 or 3 algorithms for the same problem and I want to choose which one is better, and then I want to implement the better one in terms of efficiency or time complexity. Using experimental study, this is not possible لأنه ما فيني أنا أعرف مين أحسن إلا لحتى أعملهم implement. طب بلكي أنا عندي 3 algorithms and I want to choose the best of them and then implement it. إذا أنا بدي أستعمل experimental study أول شيء بيقول لي you have to implement the program, you have to run it, you have to record time. So this will not be possible in this case. Number 2, how will you choose a good data set that will give you an accurate analysis? So نحن قلنا إنه sometimes data will help your algorithm perform faster. This doesn't mean that your algorithm is necessarily good. Maybe the data you are giving, you are using in this algorithm helped your algorithm to perform faster, and maybe if you change the data set, your algorithm will perform much worse. So how do I know? Sometimes it is a challenge to decide what data should I use for my experimental study. So number 2, so it's difficult to get precise measurements. It's difficult to choose good data sets. It takes time. It needs to be implemented first. So if I have a number of algorithms and I want to choose the best among them regarding time complexity, I cannot do this without implementing them. So this is all drawbacks for experimental study. The good news here, it is easier and cheaper than other sciences. It's easier, yes, because once you implement your program, once you have data sets, you can just simply run and record the time. So it's an easy way, given that you have the algorithm implemented, given that you have good data sets to use. In Java, there are a number of methods that you can use in order to record the time that your method or algorithm is taking. You can use them. We have here 2 methods in this slide. You can use them. I'm not going into data into Java details about this. It's very, very clear. I'm recording the time, the start time, and then after you run the algorithm, you record the end time, and then you calculate the difference between them, and you will get the time that the algorithm took while running. So challenges of experimental study, it's necessary to implement the algorithm. حكينا عنها. Experimental running time of two algorithms are difficult. إذا نحن بدنا نقارن بين 2 or 3 algorithms using experimental study, we have to make sure إنه كل الفاكتورز هن the same. يعني we have to implement all algorithms using the same programming language. You have to run them under the same software environment. We have to run all of them on the same hardware machine with the same properties. So you cannot change one of these factors and then compare them, because maybe these factors will also play a role in the difference. So this also is a challenge for experimental studies, experimental analysis. Results may not be indicative of the running time on other input. This we also mentioned it. The choice of your data set also affects your running time, which may mislead you about the complexity of this algorithm. So a better choice is going into theoretical analysis. Okay. In theoretical analysis, we don't implement the algorithm, we don't measure the time, we don't draw graphs, we analyze theoretically the complexity of my algorithm. And basically, the strategy that we're using here in our theoretical analysis is counting primitive operations. Counting operations, we can look at the algorithm and count how many operations will be executed in this algorithm. So to analyze the running time of an algorithm without doing experiment, يعني theoretically we analyze the high-level description of an algorithm. We count primitive operations. Okay, we count primitive operations. طيب شو يعني primitive operations? Primitive operations هن simple operations that we can break our statements into. For example, assignment key, primitive operation, object reference, creating an object is a primitive operation, arithmetic operation, primitive, comparing, accessing an element in an array, calling a method, returning. So these are primitive operations. Okay, so what will happen next? We assume that each primitive operation takes a constant time to be executed. So takes a constant time. لأنه هيدا constant رح اعتبره unit 1. يعني رح اعتبر إنه هو خلينا نعتبر إنه كل operation بتعمل run in 1 unit of time. شو ما كانت بس it's constant. So 1. And we will use the size of the input, and we will resemble the size of the input by n. While working, while doing our theoretical analysis, we have to think about 3 possibilities. We have 3 scenarios, which are best case scenario, worst case scenario, and average case scenario. For example, if I am sorting an array, okay, and I want it to be sorted in increasing order. إذا كانت الارray already sorted in increasing order, so this is my best case scenario. لأنه sorting algorithms, many sorting algorithms, not all of them, will do minimum work in this case. مش راح يشتغلوا كتير. فهذا بيكون ال best case scenario. إذا كانت الارray sorted ولكن بالعكس, most sorting algorithms will work the most. يعني حيشتغلوا أكتر لما بتكون هي sorted بالعكس. فهون نحن بنسميها worst case scenario. لما بتكون الارray منا sorted ولا reversely، يعني بالنص. فهون نحن بنكون عم نقول عنها average scenario. هاتيكم another example. If I have a method where I'm searching for an element in an array. I'm searching for an element. طيب what is the best case scenario؟ البست case scenario يعني بس امتين السيرش ميثود بتشتغل أقل شيء بهالحال لما يسائب إنه الاليمنت اللي أنا عم فتش عليه وين بده يكون موجود؟ على أول محل، على السب زيرو دايركتلي بلاقيه. طب والبست والورست كيس سيناريو ممكن حدا يقول لي لما بيكون آخر واحد بآخر محل، أو ممكن لما ما يكون موجود، لأنه لما ما يكون موجود my search method رح تقطع على كل الأري وما حتلاقيه. So صار عندي best case scenario worst case scenario. What is the average case scenario؟ average case scenario لما بيكون الاليمنت اللي انا عم فتش عليه، يعني بدي اشتغل نص الشغل مش كله ولا بس، يعني بين البست وبين الورست، يعني بيكون تقريبا in the middle of the array. So هون نحن عم نحكي عن 3 scenarios. اوكي هلا الورست والبست والافريج. هلا البست كيس سيناريو هي حلوه ولكن ما بتعطيني جارانتي. يعني مثل حدا عم بيقول لك انت بدك تروح تشتري برينتر او كوفي ماشين، فبيقول لك بس كيس سيناريو your coffee machine will give you will make a cup of coffee in 2 seconds. اوكي بس هو ما قال لك بالورست كيس شو رح يضمن لك. يعني يمكن هو بالورست كيس تاخذ معه ساعه انت ما يناسبك الموضوع. So the best case scenario does not give you a guarantee of performance. The average case scenario is very hard to calculate. يعني صعبة بكل البروبلمز نحن نفتش شو هي الافريج كيس سيناريو. يعني مثلا لما كنا عم نحكي عن السيرش كانت سهلة انه لكم بالافريج كيس الايتم اللي انا عم فتش عنه يكون بالنص، بس اذا انا عم بعمل سورت لاري تيجي تقول لي شو الافريج كيس سيناريو انه هي لنا sorted كلها ومنا reverse للشي بالنص. how can you tell me شو exactly the average case scenario? So average case scenario is hard to calculate in many cases. So the worst case scenario بيعطيني السيناريو اللي الالجوريثم فيه بيشتغل the most. يعني بأسوأ حالة قد ايه رح ياخذ الالجوريثم يعمل رن. مثل اذا انا عم بيع كافي ماشين بيجي بقول لك هدي الكافي ماشين بتعمل لك كافي، اوكي بأسوأ الحالات بتاخد 10 minutes for a cup of coffee. بيجي عندك حدا تاني بيقول لك هدي الكافي ماشين بأحسن الحالات بتعطيك ب 2 seconds a cup of coffee. ولكن ممكن ما رح يخبرك، بس انت you don't know قد ايه رح تاخد وقت بالworst case scenario. So لما انا بقول لك بالworst case scenario عم تاخد 10 minutes to prepare a cup of coffee. اوكي خلينا هيك بس مشوا لي اياها كاكزامبل. اوكي انت اوريدي صار عندك جارانتي انه ما حتكون اسوأ من هيك. فاذا كانت الورست كيس سيناريو acceptable بالنسبه لك you know انه هيدي الكوفي ماشين it will work هيك او احسن. بس لما انا بيجي بقول لك بالبست كيس سيناريو انا فتحت لك اياها للورست كيس سيناريو ما بعرف you don't know قد ايه بياخد بالورست كيس. so الورست كيس سيناريو بيعطيني جارانتي. That's why in our theoretical analysis بالنسبة للtime complexity رح نحكي على طول عن ال worst case scenario. ال worst case scenario بس ما نحكي عنه بنقول big O of. يعني لما نحكي عن ال big O بنكون عم نحكي عن ال worst case scenario. أنا حوقف الفيديو هون. بالفيديو الثاني حنكفي complexity و big O calculation.